Hello everyone. Today I am going to discuss the second problem of AtCoder regular contest 171, which is Chmax. So I found this problem quite interesting. So let's discuss the problem statement first. We are given a permutation P, P1 to Pn, and we define FP as the following procedure. The procedure is what? So initially we have a sequence from 1 to n, and as long as there is an integer I such that bi less than p of bi, perform the following operation. We'll find the smallest j such that bi less than p of bi, then replace bj with p of bj. So let's discuss this with one sample example. So let's say our p is 2314. So let's copy this. So let's say p is 2314. Now what is the operation? We'll find smallest integer such that initially our b array is what? Initially our b sequence is nothing but 1 2 3 and 4. Now we will find the smallest I such that bi is less than p of bi. So now you can see the smallest I is 1 such that b1 is less than p of 1. What is b of 1? B of 1 is 1 and it is less than p of 1. So what will we do? We will replace b1 with p1. So after the operation, our array will become what? Our array will become 2 2 3 and 4. Okay. Now again check that. Now again find the smallest index such that bi is less than p of bi. Now again b1 is less than p of 1. P of b of 1, p of b of 1 is p of 2. So b1 is what? B1 is 2 and p of 2 is what? P of 2 is 3. So again replace b1 with p of 2. So our new b array becomes what? 3 2 3 and 4. Now again find the smallest I such that b of I less than p of bi. Now let's say b of 1. Let's compute what is b of 1. B of 1 is 3. Now p of b of 1 is what? P of b of 1 is nothing but 1. So I should not be that index. Now let's check b2. B2 is 2 and p of b2 is what? P of b2 is nothing but 3. So we'll our smallest I is 2. So we'll replace b of 2 with p of b of 2. So our b array becomes 3 3 3 4. Now we'll check. We can't find any such I such that b of I less than p of b of I. So our process is complete and our final array is 3 3 3 4. And this is only the possible permutation such that our end array is 3 3 3 4. Okay. Now we have to find all such p's, all such permutations modulo this integer, this value, such that the end array after the process is our given array. Okay. So we will have some observations here. What are the observations? So let's talk about some observations. Our first observation is obviously our constants. Our constants is what? Our constant is on n is 2 into 10 to the power 5. So possible time complexity is order of n or order of n log n. Okay, order of n or order of n log n. Now what is the brute force approach? Brute force approach is will check all the possible permutations, which is order of n factorial, and for every permutation we will try to compute the final array, which will be I think n square again. So order of n factorial into n square. So if n is around 8 or 9, this our brute force algorithm should pass. But as the value of n is 2 into 10 to the power 5, we have to think smarter. So what are the observations we can make? So the first observation is that if something like p of I is less than equals to I plus 1, then the if p of I is less than equals to I plus 1, then the value of that index, then the bi will not change. Bi will not change. Okay. So that is the first observation we are making, that here you can see that p of 3 is 1, which is less than I plus 1. P of 3 is less than 3, so the third value will not change. And p of 4 is 4, which is less than equals to 4, so fourth value will not change. But the other values which are pi is greater than I plus 1, then those values will change. Now in which like exactly what the value will become. Now let's take our final array 3 3 let's use another color. So 3 3 3 4 is our final array. So here we are checking that the permutation, in the permutation, these two values will be 3 and 4. Okay, these two value will be 3 and 4. Now the second value will become what? Second value will become our the third value. So here you can see that second value is becoming third value. So second value is becoming third value. So let's consider some graph, right? So we will be considering some graph. So the second value is becoming the third value. So we'll take one edge between 2 to 3. Now we'll check the first value is becoming the third value. Now we'll try to connect 1 to 3, but 3 is already connected to 2. So we'll take an edge from 1 to 2. Okay. So what the sequence will happen? First, 1 will convert it to 2. Okay, then 1 will convert to 3, and after that 2 will convert it to 3. Okay, now let's take the bigger case. You will understand it much better, this case. uh, Let me write here. So now what I am saying is that uh, here the 8th value is 8, so let's consider an 8 here. Now the 7th value is becoming 8, so there will be an edge from 7 to 8, because 7th value is becoming 8. Now let's take the third value is becoming 8 also, so we try to connect 3 to 8, but 8 is already connected to 7. We will take that every value should have only one incoming edge. So we can't connect 8 to 3 to 8, so we'll connect 3 to 7. So first 3 will change to 7, then 3 will change to 8, and after that 7 will change to 8, right? And for 6 there are three values, 6 6 6. So 6, there is an edge, there is a node 6. Now we'll take but second value is becoming 6, so there will be an edge from 2 to 6. Now the first value is becoming 6, so there will be an edge 1 to 6. Okay, 1 to 2, sorry. So these are two graphs, you can say two subgraphs in the given array. Okay, now how will we solve the rest of the cases, right? So here I am saying that so 3 is connected to 7. So in the p array, so let's write p array first. Let me write in text format. So p array, the 1 is becoming 2, so p of 1 is 2, right? Now 2 is becoming what? 2 is becoming 6, so it will be 6. Now 3 is becoming what? 7, so it will be 7, right? So these values are constant. Now 4 is already 4. Okay, 4 is already 4, so let us ignore this case. Now we are only considering the graph. Okay, so we'll be rejecting all the cases now where ai is I plus 1. Okay, now 5 is 5, so we are also not considering the case. Now 6 is also 6, so we will not consider this case, minus 1. Now 7 is becoming 8, so it will be 7, and again 8 is 8, so it will be minus 1. So initially we are building this p array, or let's call it as h. Okay, now this is our the all the positions which are not minus 1, these are fixed, these positions are fixed. Okay, now we'll try to fill all those minus ones. Now how we can fill all those minus ones? So we'll check which are, so I am saying here, I have told that if pi less than equals to I plus 1, these values will not change. So we'll try to take what are the possible values such that this value is less than equals to I plus 1. So here you can see that 1, 3 and 4 are available, because 2 is already taken, so there are 3 possible cases here. Now now one value is occupied. Now here minus 1, again there is minus 1. So what are the possible cases? 1 3 4 5 is there, but one value is already taken, so there are also 3 cases. Now 3 cases. Now here 6 is also minus 1. Now we'll put 6 here, but 6 is already taken, so this is gone, this is gone. So there are only 2 possible values, right? 2 possible values. Now 7 is already taken, so there is only one possible value, so this is 1. So our at the end our answer will be 3 into 3 into 2 into 1. So I hope what I am doing you understood, that when there is a minus 1, we will check all the possible values that are not occupied, and we will try to take one of them. So here from 1 to 3 4, 2 is already occupied, so we'll take anything from 1 3 and 4. So we'll have 1 3 and 4, we'll take any of one of them. Now this is also -1, so we'll put 5 here, but as in the fourth case we have taken any one value from this 1 3 and 4, so we'll take so we'll have three choices, right? We'll have three choices, so we'll be 3 into 3. Okay, 3 into 3, 3 for the fourth position and 3 for the fifth position. Now for the sixth position, 6 is already taken, and we have already taken two values in the for the fourth and fifth case, so we have only two choices left, so it will be 2. So now three values will be cut, only one value will be left. Now for the seventh position, this is already present. For the eighth position, there is only one value, only one choice left, so our answer will be 3 into 3 into 2 into 1, which is 18. So our answer will be 18. Now let's jump into the code. Here there are some cases where answer will be 0. What are those cases? Let's discuss those cases. Now the first case where the answer will be 0 is quite obvious. That is, we will have only those values. AI should be always greater than equals to I plus 1. That is the first case. If in any condition where AI is less than I plus 1, any index, then answer will be 0. That is the first case. Now there is a special case. Let's take the case. Let me write it here. Let's say 3 3. The case is what? Let me delete something. Let me write the case. This is 3344 3344. So you are seeing that there is an age from 3 to 4. Okay, and there is an age from 2 to 3, and there is an age from 1 to 2. This case is not possible. We will be only checking that when there is an inward edge. Okay, there is an inward edge, and this value is 3, right? So 3 will be at the end of one chain. 3 will be at the end of one chain. So here 3 is not the end of the chain, so the answer will be 0. So we have to check if there is any value AI which is present. AI should be at the end of the chain. If AI is not at the end of the chain, then answer will be 0. So let's check this. P is for taking that what is the end of this chain. Okay, and D is for what? D is for the last value of the chain. Okay, so let's say let me construct this case for this case 6684 5688. So so we'll be iterating backwards. So D of 8 will be first 8. Okay, now when we are at the seventh index, we are checking that D of 8 is 8. Now we'll check that we'll mark D of 8 as 7. Okay, D of 8 as 7. Okay, now we'll mark D of 6 as 6. D of 6 will be 6. Similarly, D of 5 will be 5. D of 4 will be 4. And now when we are checking, there is an 8 present, so we'll mark age between a 3 and D of 8. D of 8 is 7, and mark D of 8 as 3, like that. I hope you get it, how we are filling D values. Okay, now P will be for marking the end of the node. Now P of 4 will be P of 8 will be 8. In this case, P of 4 is 4 and P of 3 is 3. Okay, so when we are at some index I, we will check that the value P of AI is end node or not. So for any value AI to be end node, P of AI should be AI. Okay, so here is the catch that AI should, if AI is less than I plus 1, or the end node of AI is AI. If is not AI, then our answer will be 0 and we are exiting. Okay, and we are marking the value of each I as each I is for the pointers, right? So this is the each array I have already told. And we are taking some difference array. Difference array is nothing but the number of elements or that are occupied. So at each step we are doing d5 plus equals to d5 plus 1, the previous one, number of occupied elements. If hi is equals to minus 1, that means we have to check that there are total I plus 1 elements, and from those d5 elements are occupied, and we will be multiplying this with answer, and we are incrementing the value of d5 by 1. And if it is not not minus 1, we are doing def of hi minus 1 plus equals to 1. At the end we are printing answer. This problem is quite interesting to me, and if you have any doubt in any part of the video or explanation or the code, you can always write in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.